Now that we have the parts machined, it's time to put this thing together. My notes list all the tools required to machine as well as assemble it. I've worked hard in this design to keep the tools as simple as possible. Outside of probably maybe a 1/8 reamer, you probably already have everything in stock. This video is broken into two parts because of its length and detail. Please have a good understanding of the general notes and the assembly notes. Installing bushings is typically done with some type of sealer or adhesive. I like to use a thick grade super glue. It has worked for me for decades and I stick with it. I also state that you will need to hone the hole prior to installing the bushings. My machine is set up to bore the holes round and to the size that I require. If your machine made them undersized, just hone them prior to installing the bushings, but know the diameters that you need to meet for the proper press fit. My little homemade hone is made with an old long 3/8 drill, sliced down the middle, some cheap sandpaper. I'm using 220 grit here. Don't install too much paper. The fit should be fairly loose with just a slight amount of resistance. Keep your drill at a low speed and a rapid in and out motion, checking your work often until you get just the right resistance. The purpose of this bushing is to keep the shaft centered about the base plate. Is it required? Is it critical? No. But having all your work concentric makes it look professional. Now I'm lowering the bottom bearing or bushing onto the base plate and then flipping it over, and I will be transferring one of the three holes. I have learned by my mistakes. Transfer one hole, install a bolt, transfer the second hole, and that's the process we're going to be doing here. So I've transferred one hole using an old dowel pin that's sharpened to a point. That's done easy enough. This is my $54 drill press, and this is my hand tapper. I highly recommend some type of tap guide or hand tapper. It just makes life easy. Now I've designed this with a 1-inch hole so that a standard gun or plug tap will tap to the bottom, leaving enough threads for a 1-inch bolt. So you don't need to go in with a bottom tap. I do recommend that you do clean the holes out from the chips that might be compacted in the front. Now this bushing probably isn't really critical once you have two holes in it, but I mean two bolt holes transferred, but it is critical with one because you can still slightly get it out of location. You should also remember which hole you've drilled and tapped. Mark it with a magic marker, or if you have a good memory, there is a clocking because of the dowel pin hole. So here we are, repeating the process. I will speed this up because it's just repetitive, but I want to clearly reinforce. There's the transfer punch. I put a 1/4-inch dowel pin in my cordless drill, brought it over to my disc sander, sharpened it to a point. Been using it for years. If the center punch is not deep enough, I will open it up periodically so that the drill, the 1/4-20 tap drill, has a clean point so it doesn't drift. Again, I've learned from my mistakes. I've made a lot of junk over the years. My work today, I am proud to say that mistakes are seldom made because I've made them in the past. So again, two holes are transferred. Now we're doing the third one. I typically only like to hit the transfer punch once. Here you saw me doing it twice. Doing it twice will sometimes lead to two holes or two center punches. Feel free to fast forward through some of this stuff or stop it if you need to watch something in greater detail. Remember, there's a full range of machinists out there hopefully making this project from the beginner to the most expert level. The order in which this machine is assembled is critical, though. We have to machine the base first. Here I am talking to myself about just cleaning the chips out. Clearly, they would do no harm. They're going to be encased in a set screw coffin, more or less, but just old practice. We're going to save the dowel pinning for the end when we have a fully functioning machine. This machine has two uprights, but one upright is all it's required to make this machine function. The second one offers support for the machine base. Yep, I like tight. So the next step we're going to do is start working on the vertical uprights, or as I call them, upper and lower struts. One gets a bushing. The lower right hand or left hand, I have not figured out which hand is which, because the machine is round, so you can spin it around. Again, my hole is machined to size, so if your hole is undersized, spend a few minutes getting it to the right size before you install your bushing. I'm also putting a little on the top surface, since this bushing is also going to be acting as a thrust bearing for either the crank or the pulley, and we'll see that much later when the machine is assembled. I don't own an expensive hydraulic press. Yes, I could put it in the vise to press it in, but typically for sleeves, I pound them in. For bearings, I will use the vise. Wipe off the excess glue and use some acetone if there's too much adhesive on the material. I've made the upper portion of this machine adjustable. It doesn't need it, but it just offers a little bit of extra variability on this machine. All the screws on this machine were removed and Loctite added and then reassembled after the machine was operational. It did require a break-in period. I ran it for about an hour to get everything broken in. So we have both struts being assembled. One can be set aside. We won't use it until the very end of the second video. But the upright that has the bushing and the mounting holes for the upper bearing, we will be using for the next probably several hours. These are the upper swivels. Now, I'm not installing a washer yet. I recommend that you use a 1/4-inch flat washer between the swivel and the upper strut. I take it apart on part 2 and then install the washer prior to transferring the holes from the upper machine platform. Piece mark 6. Okay. Yeah, here I assembled the wrong strut to the wrong part. I put the right and the left backwards, fixing my mistake here. You can count the number of times that I dropped that Allen wrench during this process. It's about a half a dozen. That was the first time. So that we just set aside until much, much later. There's also an order in which to assemble the struts. The thrust washer that you see facing me right now is placed in the proper order or direction. That'll be used against the crank side. So here I'm taking a upper bearing which has been machined to size. For me, that diameter was 748. My bushings measured 750. My larger bushings with the thrust bearing surface measured 752. So those bores were 750. Because of the press fit, the bores will contract and make them smaller. So every time you press in a bushing, unless the bushings have been pre-machined and pre-engineered for the proper press fit, they need to be honed out. Only takes a few minutes. I typically don't use any lubricant. At some point during this video, I do use a little bit of alcohol, mainly because the sandpaper is getting a little loaded up from all this. Didn't change the paper at all throughout this whole project, so whether or not you need lubricant, I don't know. Works fine for me, typically without. So I am checking and rechecking and checking. So I'm taking a small piece, and what I do is I install it under, make sure it doesn't wrap around more than once. This gives me just a little bump in the diameter. There's almost zero friction going on here. You'll get better at honing the more you do it. If you go oversized on these bushings, they're cheap. They're about $2. No big deal. You notice I'm not wiping down my work. I'm just using an air hose. Now, as tight as this is, it's actually too tight. It will need to be loosened up just a little bit when the machine is assembled. So here I lay out the top and the bottom of the hole so that when I clamp it against the mating part, see the flashlight on the bench, I look inside the hole so that this bracket is positioned central to the set of tapped holes. I'm also using the lower brace as a guide to help hold it steady. I will flip that around later. Position the clamp so that I can get one hole, transfer it, and do my one punch. I look to make sure it's in the middle of the two lines. I drill it. This is my $30 drill press vise. The part is actually squared up. I think from the camera angle it looks a little bit off, but I do use a machinist square to square up my work before drilling. For fluid, I typically use WD-40 for aluminum for tapping fluid. Don't over tighten this screw. Now I'm turning the bracket to its proper side, leaving it loose. Sliding it on the assembly, allowing the bore to position the bracket, and then positioning the bracket square to the base. So I want the bottom square to the base. I want the bracket perpendicular to the shaft. Once I'm happy with this, I'm going to tighten that 1/4-20 cap screw and then transfer the second hole. You notice the dowel pinhole that's there. Again, that'll be much later. You notice that the bottom bracket has been turned around. It's no longer supporting the upper bearing. That was only done just to help me hold things still. Kind of gives you a third hand. So the process is here is disassembly, drill, tap, reassemble. I think you're catching on. Put it in your vise, square up your work, just using a piece of scrap paper to stop the aluminum from being scratched. Now, I've laid out the bottom of the lower bracket, and I will also lay out the base. I want to position the bracket so that it's central to the holes in the base. I just want it to be, I want it to look good. If the holes were off a few degrees, it wouldn't matter. But it only takes a few extra minutes to do the job right. Now, the shaft will bind a little because we're pulling it over to one side. Don't worry about that. The shaft should be snug, but not tight. Again, transferring one hole at a time. Takes longer, but it guarantees a... I'm saying, don't put the dowel pin in yet. I'm going to do that later. So one in the base, one in the upper bracket or bearing, and one in the crank bearing. There's a lot of time spent assembling, disassembling, reassembling. Yep, I know. But it makes real easy work out of quickly made parts on a CNC and a dynamite assembly. I have lots of chuck jaws. I have aluminum, I have steel, I have wood, I have hardwood, softwood, I have plastics. I don't like to damage my material. You may have noticed at this point that my aluminum probably looks a little different than yours. If you follow me on Instagram, you'll see that I do my own home anodize. It's a simple process. It's not for everybody, I understand. It's diluted battery acid in a battery charger, 10 amp battery charger. I got my setup off of somebody from YouTube. Well, I should say I got my design from him, built it myself. My only word of advice here is the through holes that I'm using are 1/4 inch and my bolts are 1/4 inch. Doesn't allow for a lot of slop. You may want to open the holes up a 1/64 of an inch to give you a little bit of extra clearance. Sometimes the threads bind a little. They're actually binding here in this process. Not too bad, but they are. Now I'd like to say that this shaft runs perfectly freely here, but it doesn't yet. You can see that the 1/4-inch dowel pin actually has trouble going in the 1/4-inch hole. I think I might have picked up a little bit of burr when I did my countersink. I know it looks like I'm hitting it more than once. I'm just driving it to the front and then hitting it once. And again, it's tight. Pliers to the rescue. And what are we going to do? We're going to completely disassemble this. It would be faster with air tools. And that's it for part 1. See you on part 2.